Okay, so in this one, um, basically, it says that ozone is an atmospheric trace gas that occurs naturally in the stratosphere. It's also formed as a consequence of human activity in the troposphere, right? So this is what I've tried to talk to a lot of you about. I keep mentioning this. So, right, ozone is in the, it occurs in the stratosphere naturally. That's our ozone layer. And then it's also formed in the troposphere, which is kind of the area where we live, and that is pollution in the troposphere, but it's normal in the stratosphere. So if ozone is in the stratosphere, it's good. I'll put a plus here. And if it's in the troposphere, it's negative, it's bad. And so that's a big thing that students tend to get confused with, is they get confused as to like which type of ozone is good and which type of ozone is bad. So now it's asking about the type of solar radiation that is absorbed by stratospheric ozone, and then it wants to describe a human health benefit. Okay, so for this one, the type of ozone or the type of radiation, you think, let's see, you think that it's, they're like what specifically UV, UVA, UVB, something like that, but really, all you have to do is say ultraviolet to actually get credit. So that's really nice, I think. You can say, wow, so many text boxes. You can say UVA or UVB, but really, as long as you say ultraviolet, they're okay with that. So, and then they want to say like a human health benefit that results from solar energy. So think about it, like if you go out in the sun, what are some bad things that can happen to you if you go out in the sun, right? So bad things are like skin cancer, sunburns, you can damage your eyes, right? That's why we wear sunglasses. So those are bad things, right? Well, they add a benefit from absorbing the solar energy. Oh my goodness, I'm just making text boxes left and right. So all you have to do is you just have to take these bad things and turn them into good things. Okay, and that would be your benefit, right? So you can say, instead of you get skin cancer, you can say lower rates of skin cancer. Okay, or if they say sunburn is something that you can get if you are exposed to solar radiation. So you could say like less sunburn or a lower rate of sunburn, right? Or you could say like eye damage, you could say a lower rate of eye damage, right? So you just have to take that bad thing and turn it into a good thing, because they say they want a human health benefit instead of a a negative. So that's all you have to do for that kind of part. So that this part is not too bad. You read this and you're like, oh, I got this, right? It's not too bad. Now we get to the second one. Okay, the second one says the absorption of solar energy by stratospheric ozone causes ozone molecules to undergo chemical decomposition and formation. Okay, so if you remember that, that means that we're constantly forming ozone, and it's constantly breaking down. Okay, it's just going back and forth, back and forth. So it says describe the chemical processes that lead to natural balance between ozone or decomposition and the formation of ozone. So you can either use chemical, or you can actually you can type your answer. Okay, and so this is where I think this part is kind of hard, because like for example, if I was going to do the equation, right, we have ozone plus UV light equals like O2, which is normal oxygen, plus like an O radical. Basically, this would be like it's a charged ozone. And then you could write it, let me get a different text box. You could also write it like this. So it looks like you know, you can write it either way. Oh dear, all these text boxes. Okay, I want to actually get back to this one. I just might delete it all. Wow, now I know where I usually write with my pen, right? This is crazy. This is what I meant to write. Okay, so either one of these, right, is a formation reaction, or a decomposition reaction, sorry. Or you could say, like, you could also say ozone absorbs UV radiation, producing oxygen molecule and oxygen atom. Right, so you could write it either way. Jeez, I'm making these text boxes everywhere. So either one of these would be okay, right? So that's the decomposition, and then the formation. You know, you can write is basically the opposite, which is kind of nice because then you don't have to worry about you don't have to worry about you really only have to like memorize one equation. Make sure. Yeah. Okay. So you can write it either way, right? Either one of those will be okay. Either one of those is forming ozone, right? And then you can say that oxygen molecule reacts with oxygen atom to form ozone, or let me see. Will this let me do another? Yeah, cool. Or you can say that oxygen molecule reacts with UV to form ozone. Okay, so you can kind of do it either way. They actually even allow this. And right now I'm just looking at the key, mostly because I want to make sure I get these equations right. I just wanted to show you, you know, the variety of things that they actually allow, but also that, you know, it's kind of detailed what they want. So like instead of doing the two steps, like this step is decomposition. I'll put a D here, and this is the formation. So you can do it in two steps like this. You could also just, you know, write it like this, because this would be your decomposition right here, and then this would be your formation here. So you can do it either way. But personally, I find this part of this equation to be really hard, just because you have to memorize those formulas. And then the next one, there's actually a part where they want to memorize. They want you to memorize the formula too, or you know, you at least have to know what the formula means, or like even if you don't memorize the formula, you still need to memorize like what's going on. So I think that part is kind of hard. I like the parts where we can take all of our knowledge that we've learned and then apply it to something. I like that part better. I think those questions are a little bit easier because you know, there's more answers that could be right. Where in this one, you know, there's a few things they allow, but there's basically like, you know, one answer. Now this part is also going to have an equation part I, but also if you notice the equation part is a small subset of this FRQ. So even if you don't have the equations memorized or whatever, you could still do the FRQ, right? You could still get some points, some partial credit, which where these FRQs, there's usually at least one part that you can do, right? And points are points. So even if you read an FRQ and you're like, oh, that one's really hard, you know, save that one for last, come back to it, But then when you come back to it, try your best, at least write something, right? And then at least you can maybe get some point, right? There's probably something, if you've done what you're supposed to do in this course, there's probably at least something of each FRQ that you can do, right? Even if you don't know everything about every FRQ review. So in this one, now they're talking about CFCs. So they say the Montreal Protocol of 1987 provided a global framework to phase out chlorofluorocarbon production and use. Although the Montreal Protocol has led to a dramatic decrease in CFCs released in the atmosphere, stratospheric ozone destruction has decreased only slightly. And then they want you to explain the process by which CFCs lead to the destruction of the stratospheric ozone. And this where why we're going to talk about how losing CFCs is still not led to a rapid decrease in the destruction of stratospheric ozone, which is something that a lot of folks don't realize. Okay, so these are your chlorofluorocarbons. Okay, so when they react with UV, so you could say this in equation form, or you could just, say it in word form. They produce, they basically produce this chlorine radical here, right, which just has a negative charge. And then that chlorine radical, what happens with that guy is this chlorine reacts with ozone and produces ClO plus O2. And if you remember, O2, okay, if you remember from our previous slide, right, O2 can react to form oxygen or to form ozone, but then this ClO or this CCl2F can actually go ahead and form another chlorine radical, which then break up more ozone, or this one, they can actually react and reduce more, or not form ozone, but like break up ozone. And so then it's basically, it's like a chain reaction. It just keeps happening, right? So there's a couple of reasons why the CFC, rapidly reducing CFC emissions has not reduced the destruction of ozone. And the reason is, there's a few reasons. CFCs are actually pretty slow to migrate into the stratosphere. So they don't just like immediately end up in the stratosphere. It takes them a while to get up that high. And so even if we were to like reduce CFCs, let's say today, right, the CFCs that were released today will take a while to make it to the stratosphere. And so it's not like, whatever's there today is done. There's still gonna kind of mingle up there. And then these products have a really high lifetime, and in the atmosphere, especially the chlorine. So the chlorine just stays up there for a really, really long time, which is, not great when you're something that continually causes a chain reaction that breaks up the atmosphere or the ozone layer. And then we're also releasing other ozone depleting substances. Okay, so all of that is really causing that issue. Okay, so that's those are some of the main reasons, and a big one is 1 and 2 are really the main reasons, but 3 is kind of a little, so they give you credit for it. Okay, now what is an human activity that leads to the formation of tropospheric ozone, right? So that's the bad kind that is down where we live. Okay, so that's one of the ones that we don't like, or that's the type of ozone we don't like, right? Where we've previously been talking about ozone that we do like. So what is something that leads to the formation of tropospheric ozone like? Yeah, that's perfect. Burning fossil fuels. Okay. Um, okay. Any type of burning fossil fuels. So like for example, like cars, factories, energy plants, stuff like that. All of that stuff will form tropospheric ozone. Okay. Another thing that release tropospheric ozone, just so you've got both of them in case you want it, is releasing VOCs, volatile organic compounds. Okay, so both of those um, will give you credit for that part. And since it only wants you to identify, you don't have to say what about it, you just have to say that it does. Okay, you don't have to like come up with some really great explanation. Okay, but then the next part, they do ask you to explain. So then you're going to actually have to, talk about something. So the second part says, explain why tropospheric ozone peaks in the daytime. Okay, and we've talked about this a little bit in this course. I know I've seen you guys talk about it a little bit in discussions, and I think we talked about it last week. So what is it about daytime that makes tropospheric ozone form? So tropospheric ozone peaks in the daytime because sunlight, it's what they call a photochemical reaction. Yes, exactly. And it requires sunlight to proceed. Okay, so tropospheric ozone requires sunlight to be created. So that's why they consider it a secondary pollutant, because it's not actually released, but things that are released from burning fossil fuels then react with sunlight to make ozone, and so that they consider it a secondary pollutant. Okay, and then I think this question had one more part. Yes. Okay, so they want you to identify. Okay. They want an ecological impact, and then they want you to so you don't actually, since they ask you to identify, you don't have to explain it. You just have to identify it. You just have to, what is something that is a negative ecological impact with tropospheric ozone, and then a negative health impact. Perfect. Yeah, yeah. It damages or irritates your eyes. That's a perfect health impact. So for like since you did health one, I'll do ecological. We could talk about how it damages plant tissue. It inhibits photosynthesis. And it can, so not only does it irritate us, right, our respiratory system or our eyes, but it can irritate other animals. Okay, and then it says it does say where'd it go? It does say that you could talk about whoa, oh dear. Okay, so let me write that back in case anybody watching the recording needs it. Okay, so plant tissues, photosynthesis, okay, and then over. Yeah. Okay, and then we talked about irritating the eyes, right? Okay, it can also affect your respiratory system, just like it can other animals. And then you can basically, what I was getting ready to say before I deleted it, is that you can mention that it is a greenhouse gas and it contributes to global warming, but you'd have to explain. You can't just say global warming. You'd have to explain like how, for example, global warming would cause more mosquitoes to be around, which could cause us to get more mosquito-borne illnesses, and that would hurt our health. You could say something like that, but you couldn't just say like global warming, because global warming doesn't directly hurt your health. You'd have to explain why. So that's so you could put that as a choice, but you'd have to explain why. And so then I wanted to talk about this other FRQ. So this FRQ, the reason I wanted to talk about this one is because, like the last one, it relates very much to what we're studying right now, but it also requires some math. And so I wanted to kind of talk about the math a little bit because I've gotten some questions about the math. So anytime we have math on an FRQ, you must show your work. Okay, you can't, even if you have the right answer, sometimes you don't get any points for showing the right answer or for just having the right answer. Sometimes you get points for having the right answer and then points for showing your work. Sometimes you have to show your work and have the right answer in order to get points. But you never get points for not showing not showing work, right? You can never get full points anyway with not showing your work. So it's really, really important to show your work on the FRQ. So, and I also want to show how, another example about how a math FRQ doesn't necessarily always have math. The whole thing isn't math. So there's usually, even if you say, whatever, I'm not doing math, I can't do math, whatever, there's still something that you can do. The whole thing, like not all the 10 points come from math. So here we go. This one says that coral reefs are produced when corals acquire calcium ions and carbonate ions from seawater and deposit solid calcium carbonate to form their exoskeletons. Scientists are concerned that relatively rapid decreases in ocean water pH is going to hinder the deposition of CaCO3. Basically, CaCO3 can dissolve, acid will dissolve it. And so it'll basically dissolve the corals. And so it says the graph above shows the amount of CO2 dissolved in ocean water and ocean water pH shown in parentheses 1850 and the predicted changes through 2100. Okay. So this was I think this was written in 2011, but they usually write them a couple years before. A good rule of thumb, if you want to, for the FRQ to kind of see what they're going to talk about, at least for as far as current events, is it's usually stuff that's like 2 to 5 years old. So something that's happening like right now, a current event, would not be something that they would put on the AP exam. They'd put something that's probably like 2 to 5 years old. So if you look back at, things that were like 2 to 5 years ago, then those would be the kind of current events that you'd see in your FRQ. So anyway, this is what the graph looks like. This is the background information that they give you. Okay, you can see the pH is decreasing as the carbon dioxide is increasing. Okay, so then they want you to explain how the amount of dissolved CO2 in the ocean results in a decrease in the pH of ocean water. So basically, you need to explain like what's forming, right? Carbon dioxide basically reacts with ocean water and forms carbonic acid, right? Which you show the equation, or you could do the words. Again, you see how it's pretty chemistry based. I like to do the words part. So we could say when CO2, you could say CO2 or carbon dioxide, it doesn't matter. Um, um, and the specific acid, I'll write it here just in case you're one of those folks that likes to remember that. It forms an acid, which is carbonic acid right here. So that's basically what causes the decrease in the pH, is because CO2 is reacting basically with carbonate in the water and forming, or reacting with water and forming calcium carbonate, or sorry, acid, hydrocarbonic acid. Jeez, I am like really struggling tonight. So it forms the calcium carbonate, and then you get the carbonic acid. Sorry, I just had all these like messages coming in. Reading those instead of paying attention to what I'm doing. So explain why the movement of carbon in the ocean has been increasing since 1850. Okay, so basically, why has carbon in the ocean been increasing since 1850? Basically, since the Industrial Revolution, right? Now, you don't have to write this part. I'm just kind of using it to explain. So basically, since the Industrial Revolution, we've been releasing more carbon dioxide in the atmosphere, right? Well, the ocean is known as a carbon sink. And what that means is that the ocean can absorb a lot of carbon dioxide, okay? Okay, so this is a good thing, right? Because if the ocean didn't act as a carbon sink, we would have even more carbon dioxide in the atmosphere, right? Which would be even worse, right? More global warming or global climate change. But when it does absorb the carbon, it forms that acid, right? So that's what's basically causing that reduced pH. You know, it can absorb a little bit and the pH won't change that much, but because we've been releasing so much CO2 and the ocean has been absorbing so much CO2, it actually now is reducing the pH of the ocean, which is a bad thing because a lot of times the critters in the ocean, their pHs are adapted to a very, very narrow range. And so the pH is basically changing faster than they can adapt to it, especially corals. They have a very narrow temperature, sunlight, pH, everything range. They're really, really sensitive. And so now it wants to do the math. But you see, we've done all the way to part C without any math. So, and let's see. So that was like 3 points on the FRQ. So we've done 3 points already that don't involve math, right? So now it says, in order to model the effects of ocean acidification on coral reefs, some assumptions can be made. Use the assumptions in the table below to perform calculations. Okay, so it says assume global area of corals is 2.5 times 10 to the 11 meters squared. Assume that corals only grow vertically. The average vertical growth rate is 3 millimeters a year. We know that's not right, right? Corals actually, they actually grow like this. They're like this. They just grow out like this, right? But we're assuming they grow vertically. We're assuming the density of CaCO3 is 2 times 10 to the 3 kilograms per meters cubed. So right now it wants to calculate the current annual global increase in volume in meters cubed of CaCO3 a year. Okay, so I'm going to actually do this one with the pen, or I'm going to just like not type it because I don't think it'll work as well. But my pen's not working on slideshow for some reason, so I'm gonna have to, yeah. So I'm gonna have to kind of write it with my mouse. So it's gonna be a little slow, but I think it will make more sense. So here's our area, right? Meters cubed. And we know, even if we're not really sure what we want to do, we know that our answer needs to be in meters, or we're in meters squared and we need meters cubed, right? So we know we need to do something to get meters, right? So what I'm going to do is I've got that, and then we have 3 millimeters a year. So what I'm going to do is I'm going to take my 3 millimeters a year, and they suggest that you do it all at once, but I don't like to do that. So I'm going to do it. I'm going to convert my millimeters to meters, and then I'll put that in my equation up there. So I have 1,000 millimeters in 1 meter. So then we'll have 3 times 10 to the negative 3 meters a year. Okay, and now I can take this and put it up here, right? And so now I'm going to multiply that by, I'm sorry, it's like running so slow. I just didn't think it would make a lot of sense if I tried to write it in a text box. And I'm going to write it like this when I'm doing my math, okay? So now I know I've got meters squared times meters, so I know my units are going to be right. And it's meters 3 per year, which makes sense because it says annual right here, right? So we have 2.5 times 10 to the 11 times 3 times 10 to the negative 3. Okay, so basically we're going to take this 11 and minus 3 from it, and that's going to give us 8. Okay, so then we can do 2.5 times 3. Okay, so you know, you can just do the math. You can do it in your head. You can add it. You can add it up, or you can multiply it. I'm just going to add it up because multiplication is not my strong suit. So that's 6, 7, 7.5. And you know you can't use a calculator on the AP exam either. So they're going to give you numbers that like divide well or add well, you know, that kind of thing. So if you're starting to get like some really crazy random numbers, you're probably not doing it right. Just because they're going to give you things that are easy. And then we'll do 10 minus 3, which is 8. So then we'll have 7.5 times 10 to the 8 meters cubed a year. Okay, and that's our answer. And we'll get credit for this because we showed our work, right? This one actually says you get 1 point for setting up the equation correctly and 1 point for the correct answer. Okay, so you'd only get half credit if you just had the correct answer and no work. Okay. The next part says calculate the current annual increase in mass of calcium carbonate in coral reefs. So show all steps in your calculation. Okay, so what I'm going to do is I'm going to take that number we had last time. Now, let's say part I, you didn't know how to do that. You're just like, I don't know. Go ahead and make up an answer for part I, even if you don't know how to do it. Okay, because what they will do is if you get the wrong answer for part I and you need that answer for the next part, they will actually they will give you credit for that as long as you use it correctly in part 2, right? In this part. So let's say I didn't know what the answer was and I just had like 10, right? I put 10 times 10 to the 10 or whatever. If I use that answer correctly in this part, then I would get this part correct. Okay, so if you don't know an answer, go ahead and make up one and make up an easy answer. Don't make up like 7.99862 times 10 to the 27, right? Make something easy because it's whatever, you're making it up, right? So in part 1 or part I, you would say 8 times 10 to the 10, let's say. And then in part 2, you would just put 8 times 10 to the 10 here. Or you put 8 times 10 to the 10 in this part instead of 7.5 times 10 to the 8, and then work out the rest correctly, and then you'd at least get a point for part 2. So that's kind of handy. So what I'm going to do is, I know that I need my answer in kilograms per year, right? Because it's annual. So I need to get, I have my meters cubed per year, and then I have this 2 times 10 to the 3 kilograms meters cubed. So if I put these together, I should be able to get rid of my meters units and just keep kilograms and years, which is what I want my answer to be in. Okay. So this way, I'm going to lose my meters, which I don't want. I'm going to have an answer in kilograms per year, which I do want. And then I can just do my math. So this should be, I'm not very good at writing without my pen. Kilograms per year. Okay, so 7.5 times 2 is 15. And then 10 to the 8th times 10 to the 3, you're gonna add these together. So we have 8, 9, 10, 11. So we have 15 times 10 to the 11th. Now they'll actually take this, even though this isn't correct scientific notation. If you want to make it really correct, you would do like 1.5 times 10 to the 12th. But both of these are actually correct. They'll take both of them, and they'll also take the correct answer not in scientific notation. So if you have 15 and then a whole bunch of zeros, they'll give you credit for that too. Okay, so either one of these would be correct. Okay, and for this one, you get 2 points. 1 point for showing your work, and 1 point for having the correct answer. So you'd only get half the points if you don't show your work. Okay. And now we have our third math step. It says, because of ocean acidification, it's expected that in 2050, the mass of CaCO3 deposited annually in coral reefs will be 20% less than it is now. Calculate how much less is expected in 2050 than would be now if the pH is going to remain the same. So basically, we take that number we just got in the last answer. And again, same thing. If you couldn't do part 2, but you're like, man, I know how to do this part, make up a fake answer for part 2 and make it an easy number to work with, since you're making it up anyway, and use that for part 3, and you'll get full credit as long as you do part 3 correctly. Okay, so we need to do times 20%, which is times 0.2. So when you're doing your math, and you're actually like calculating it or whatever, you can just do like 1.5 times 0.2, and then see what that is, and then kind of go from there. So I believe it's like 0.3. So then you can get 0.3 times 10 to the 11th kilograms, or times 10 to the 12th, sorry. I'm getting ahead of myself. Try and make this K. And then if you want, since that's not proper scientific notation, if you want to do 3 times 10 to the 11th, that's okay too. You can get credit for both answer. Okay, so either of those would be answer, or 3 and a bunch of zeros to get 3 times 10 to the 11th. All 3 of those answers would be correct. Okay, and then that's the end of the math part, and now we're back at word cards. So even if you don't know how to do math, you still can get some partial credit somewhere, because you can do like word cards here. Okay, so here we need to identify a negative environmental impact, and then we need to describe it. Okay, so something negative with losing coral reefs. It could be anything. Um, since we've only got a couple minutes left, I'm gonna kind of go through this kind of quickly. It took me longer to write the math than I would have liked. Okay, so we could say a negative environmental impact. We could say loss of habitat for fish, and then we could say that many fish use coral reefs as breeding grounds, shelter, nurseries, for the baby fish, and losing coral reefs, and that's not going to fit one line, so I'll do it here. And losing coral reefs would reduce the habitat for these things or activities, whatever you want to call it. Okay, you could also mean that you're going to lose biodiversity, or you could say that coastal areas won't be as protected from storms. You could say you're going to lose that carbon sink. There's lots of things that you could put here. And then it says identify an environmental problem other than one due to ocean acidification that affects marine ecosystems on a global scale. So they actually want something else that's affecting the ocean, but not acidification. Okay, so you can pick anything you want, and you just have to identify it. So you don't even have to describe it or anything. So you could talk about overfishing. You could talk about increased temperatures. You could discuss invasive species, or you don't have to discuss, sorry. You could just say invasive species, trash, plastic. I know some of you guys are actually already working on that Great Pacific Garbage Patch discussion. You could talk about pollution, like oil spills, mercury. Okay, so there's lots of things that are affecting globally the ocean. It's just acidification. So in that one, all you have to do is identify it. You don't have to say anything more about it. So that's kind of handy. So hopefully you got, and hopefully this was a good kind of review for the stuff that we've been talking about on this unit and how you can kind of apply that information to an FRQ. And also hopefully it showed you kind of how specific some FRQs be, like the one where they wanted like the chemical equations and all that detailed stuff. And also you can see that even in a math problem, there's still lots of things that you can get points for, right? Like this part E is fairly easy, and it was on a math part. So just because you see numbers or math or something like that on an FRQ, don't just automatically like skip that one and not even read it if you're not very good at math or whatever. At least read the rest. As sometimes there's usually the math is at most about half of the FRQ, so there's other places where you get points. For this one, I think it was like 6 points. So you could at least get 4 points, even not doing the math, which 4 points is nothing to sneeze about. That's 4 points, right? So anyway, hopefully that was helpful with FRQs. I think we have like 2 more of these type of subject-based reviews left, and then we'll go into the reviews for the final exam and the AP exam, and then, which this kind of was an AP review a little bit, and then we'll be done. So we've got like I think 5 sessions left before the end of the semester. So we really are kind of on the downward slope. So hopefully that was helpful. If you have any questions, I would love to answer them. Otherwise, you're free to go. That's really all I have for you. Oh, if you skip a question, is it okay to leave space? Yeah, totally. Just leave space in your answer book for the question that you missed or that you skipped. Usually they give you like a few pages per question. So I want to say maybe like 8 pages total, like 4 front and back. So just like skip one and go to the next one, and then just leave some space for that. And then you can always come back to it. Or you can, like for this one, let's say you want to answer all the FRQs and then come back to the math and kind of struggle through it or whatever, if you weren't really sure how to do it, you could just leave space for like just the math part, you know, and answer part A, B, skip C, 1, 2, 3, and then go to D and E. So yeah, you can just leave space for it.